On this Jaguar XJ, for example, I've got drive controls that include a sport mode, a dynamics mode, and those speak to the adaptive suspension, which Jag's engineers say allowed them to monitor for almost 900 parameters of the vehicle's relationship with the road and gravity, up from about 80 on a typical dead steel spring suspension. Now, whether you're monitoring 80 or 800 parameters of suspension and vehicle relationship with the road, there are really just four major technology groups that get that done. There's active pneumohydraulic. This mouthful uses a combination of pumps and accumulators to move hydraulic fluid and compressed nitrogen gas to the car's four corners as needed in milliseconds to take over the functions of both shock absorption and sway control. It's very exotic and expensive. We've driven it on the McLaren MP412C, where it keeps the car almost oddly level in corners, but also kept the ride compliant. Then there's active electromagnetic. This system replaces all that pneumohydraulic plumbing and pumping with linear electric motors at each corner. Its response can be even faster, and it doesn't strew plumbing all over the car. The Bose company of audio fame, oddly enough, is well known as an innovator in this technology, and it actually derives some of the basics from the study of waves and electromagnetics, a lot like speakers. Okay, that's active. Now on to the adaptive or semi-active technologies. These are so named because all they do is react to what the road and the car are doing. They don't actually bring their own forces to that relationship. First up is adaptive solenoid or adaptive valve. Now, your typical shock works by passing hydraulic fluid through a series of small valves or orifices, which limit the rate that fluid can move back and forth. That limits the movement of the shock and therefore the movement up and down of the car. Adaptive valve or solenoid tech gives you electronic control over those shock valves, so the rate at which fluid moves around inside the shock can be changed on the fly, therefore varying the shock's damping behavior. That brings us to adaptive magneto-rheological. It's a mouthful, but perhaps the fastest growing adaptive suspension right now. This GM-developed system uses a special kind of shock fluid with particles suspended in it that react to electric current. And simply put, that makes the fluid present itself to the mechanism more or less viscous. And that varies the damping effect in very subtle ways that can be changed very rapidly and with great range, just by varying the current you apply to the fluid. Oh, by the way, if you see a wire coming off a shock absorber like this here in the center of the shock tower, that's a dead giveaway. You've got adaptive suspension. In this case, magneto-rheological technology, and this is the current flowing through here. Now, so far, these adaptive suspension systems have gone in two directions. One is for extremely high-performance cars, and the other is for very luxurious, high-comfort vehicle applications. We're not seeing these show up in a lot of mainstream cars yet because they don't have an everyday efficiency component. They're never going to save you any MPG or make the car any less expensive. So what we're talking about here is a still mid to upper class tech if you want to divide the car market that way. But as this technology comes down in prices, of course it will, expect to see it on more cars in the sub $30,000 class.